Are questions 11 through 15 on your Chapter 3 review. Number 11. Please write an equation and then solve the equation for each of 11 and 12. So 11. What number decreased by 3.5 equals 12.7? Well, since we don't know what the number is, we're going to call that number x. This number that we don't know, we're going to call that x. So what number, x, decreased, so minus, by 3.5 equals 12.7? That's what we're being asked. It says, what is the value of x, essentially? So here's our equation. So that's step 1. Step 2 is solve. Well, you guys know, add 3.5 to both sides. And this one's not so bad. So x equals 15.7, 16.2. You can check that by plugging it back into your original equation or looking at this and saying, does 16.2 minus 3.5 actually equal 12.7? The answer, of course, is yes. Let's move on to 12. It says 12 is added to the product of a number and 5, and the result is negative 3. Find the number. So 12 is added to, so something plus 12. The product, so product means multiplication, of a number, which we don't know, so we're going to call that, let's just call it n. You can call it x, you can call it y, whatever you want. 12 is added to the product of n and 5. Well, how do we write the product of n and 5? You write 5 times n. So 12 is added to this product, and the result is negative 3. So equals negative 3. In order to find out what the number n is, all we have to do is solve. So let's subtract 12 from both sides of our equation. These guys cancel out. You're left with 5n is equal to negative 12. Divide by 5 on both sides. And you're left with your answer. N equals negative 12 over 5, or negative 2.4. Did I do something wrong? Yes, I did. Let me go back. I realized that didn't check, so I need to change my answer here. Oh, careful. Let's get rid of that guy. And that. Hopefully you caught me before I finished. So negative 3 minus 12 is actually negative 15. So we would have had right here 5n equals negative 15. We still have to divide by 5. And n then is equal to negative 3. Folks, I was able to catch myself because I realized that negative 2.4 would not have checked. Okay? So that's the benefit to being able to check yourself. You should always check yourself. Therefore, you won't move on without knowing that you are correct. On to 13. Here we have this equation. We have variables on both sides of the equation. We have fractions on both sides that need to be distributed to the things on the inside of the parentheses. However, I don't like working with fractions. So if you recall, my strategy for removing fractions so that I can just work with integers is to multiply both sides of the equation by a number that will eliminate my denominators. Well, let's find the least common denominator. In this case, it's going to be 6. 3 goes into 6, and 6 goes into 6. And let's multiply by 6 over 1 on both sides of the equation. When you do that, you have 3 things that you need to multiply on the left side. You have 6, you have 1/3, and you have c plus 1. So let's do this. 6 times 1/3 is just 2. And then you would still need to multiply 2 by c plus 1. So this is equal to. And on the right side, you also have 3 things to multiply together. Well, let's multiply 6 times 1/6. What happens when you do that is that these guys end up just being 1, which I really don't need to write, but I will. And you still have to multiply that answer 1 by 3c minus 5. That really doesn't change anything. All right, now you've gotten rid of all your fractions, and this is much less daunting. So let's solve. Let's distribute first on both sides. 2c plus 2. And of course, this side really just remains the same. 3c minus 5. And let's bring our c's to the left. I'm going to subtract 2c from both sides. Sorry, bring them to the right. These guys cancel out. You have 2 is equal to just 1c, or c, minus 5. Add 5 to both sides. And you are left with your answer. At least I think it is, until I check it. C equals 7. Go ahead, if you want to check that, plug 7 in for your c's, and make sure the left side and the right side are equal. I'm telling you right now, it does check. On to 14. 3 times the greatest of 3 consecutive even integers exceeds twice the least by 38. Well, we don't know any of the 3 integers. So let's start by saying our smallest integer is, we're going to call it x. The second smallest will be x plus 2, and the third smallest will be x plus 4. So these 3 guys are our 3 integers. Now, it says 3 times the greatest of these integers. Well, the greatest is x plus 4. So 3 times that guy exceeds twice the least, well, this is the least of the 3 integers, exceeds twice this number by 38. So I'm going to go equal. And we say this guy, 3 times the greatest of the 3 integers, exceeds twice the smallest integer, so 2x, by 38. So if I want to make the left and the right side equal, and this side is 38 more than just 2 times x, I'm going to need to add 38 to this side. 2x plus 38 then must be equal to the left-hand side. And from here, you can simply solve. Wow, this is bothering me. So you've got, I don't know what's going on there. So you've got 3x plus 12 equals 2x plus 38. And once again, you can probably solve from here, but I'll do it. Subtract 2x from both sides. You're left with x plus 12 equals 38. Subtract 12 from both sides. And you are left with x equals 26. That is not our final answer. You are asked what are the integers. X is merely your smallest integer. So I'm going to put these guys over here. X is 26. That's one of your integers. Then your other 2 integers must be 28. And your biggest must be 30. So just to be sure, you can check this. You can plug in 26 for x, and it will, in fact, check out. So those are your answers, 26, 28, and 30. All right, finally, on to 15 here. We have y's on both sides of the equation, and we have fractions. So once again, I'm going to use the same technique as in 13. I want to get rid of those denominators. And the simplest way, the fastest way I know to do that is to find the least common denominator, which is 8. And I'm going to multiply both sides by 8, or 8 over 1. Okay? Now be careful here. Once we do that, the right side is pretty straightforward. Our 8's cancel out, and we are just left with negative y. The left side, I'm going to do some cross-canceling here. 4 goes into 4 once, and 4 goes into 8 twice. So what do I have left over? I have 2 times the numerator in this fraction. So I'm going to write that out. So 2 times 3 plus y. And of course I have 1 times 1 on the bottom, but that's not important. Now, fractions are gone, and this is a lot simpler. So let's distribute the 2. 2 times 3 is 6, plus 2 times y is 2y, and it equals negative y. I'm going to take my y's to the right side, so I'm subtracting 2y from both sides. I'm starting to run out of room. I'm left with 6 equals negative 3y, and let's bring it over here. Sorry about this. And divide by negative 3 on both sides, you end up with y equals negative 2. Folks, once again, that will check. Check it yourself if you don't believe me. And remember, there are more of these if you need to see any other questions.